So I've got this Senco SD300 drill that is pretty old and useless to me at this point because of the battery adapter, and I have a lot more newer drills. So these Senco brand drills are mainly for indoor carpentry type uses. Senco makes nail guns, they make drywall, screw, I guess drills, but they have those belt feed things so you can keep putting drywall screws in at a specific height and that kind of stuff. As you can see, it doesn't really have much use. We'll be finding out what year model it is on the inside, but it's looking pretty good. As we can see from the outside, there is no over molding. The shapes are pretty bulky. The battery mounts sideways, which I'm not sure how big these 14 volt batteries were, but yeah, we can assume that they must have been pretty bulky. And there is no temperature gauge on there, there's only minus and plus. Now, I have had this thing apart before, and what I think happened was you gotta take the drill off, or the chuck off, to be able to take the rest of this apart. As in, you gotta take this piece off to be able to take the clamshells apart, and you need to take those screws in there out, and in order to take those out, you gotta take the chuck off. So that's majorly inconvenient, because if you've ever tried to take a drill chuck off, that means you gotta get the bolt that's on the inside that has a left hand thread. You gotta pull that thing out, and sometimes it just will not come out. So I got lucky. I think this one does come off, but yeah, it does have, what we can already see from the outside, it's got a permanent magnet DC motor, kind of like this. It's brushed, works on DC, works on AC. As you can see, the profile of it, the chuck is a whole 4 inches, 10 centimeters further away than, the chuck on these Makitas, and this isn't even an original chuck. I think the original chucks might be, half an inch to an inch shorter. Probably half an inch shorter. Anyway, on the external here, we got these drill bit spots here. I don't know if anyone ever used those. I suppose I could try putting something in there. So if we give it a little bit of go, suppose you can squeeze it in from the outside, yeah. I can see how that could be somewhat useful if you want to not have 3 of these in your mouth and 1 in your hand while you're on a 3-meter ladder. So yeah, that might be useful. Don't have those in the newer ones. Some newer ones have a thing down here, I think, where you can stick some onto, but yeah, design is very simple. The plastic feels really flimsy, although it is pretty thick, but it's definitely not very comfortable. It's really hard, and the shape really doesn't match your hand at all, whereas this Makita gets thinner down here. Makes it a lot easier, although I do have pretty small hands. So yeah, so if we now go ahead and start taking it apart, you see there's a that's actually not a Phillips head screw, that's 2 flat bits on it, so you can take it off with a flat blade screwdriver. You can put a lot more force into it without busting the bit. So if we Oh yeah, because it's a reverse thread. Yeah, that would make sense. Alright, there we go. Alright. Yeah, so this bolt is reverse threaded in because the chuck is normally threaded in. And the chuck just unscrews. Usually you would have to put in an Allen little angled piece in here, put this against the table and hit it with a hammer, get the impact on it. But now that we have the chuck off, you can see that these 4 screws right here, I let you take this thing apart. And this thing, I mean, if you consider that is almost 2 inches right there. So this is just the, I guess, kind of max torque setting. Whereas on this Makita, even on this, it's pretty thick. I think you can see it there. On some other tools, I've seen it really thin. But if I remember right, we got to take these off in order to take the clamshell off. But let's test it out anyway. So from the outside of the drill, we actually can't see how old it is. So we'll have to find out from the plastic date codes on the inside. I'm guessing somewhere around 2012. So now that should be all the screws, no hidden ones in there. Oh, it does come apart. Alright, well. Came right apart. Didn't even need to take the chuck off. So I was wrong about that. So if we go ahead and take a look at all the things in here, actually, let's look at that date code first. So we see these 2 arrows right here. It is PC plus ABS, so it's polycarbonate mixed with ABS. So it's not just ABS. I would have guessed from the outside that it was just ABS, but I guess the polycarbonate adds some strength there. So if we look at the date codes here, 12th month of 05. Well, yeah, I was quite far off with my estimate there, since it is now the end of 2020. This was made in the end of 2005, making this thing 15 years old. So, yeah, with that in mind, I guess we go on to the electronics. As you can see, plus and minus, there's no temperature. So if the battery starts to overheat or something, the drill just keeps going. But being 2005, it probably would have had nickel batteries, nickel cadmium or nickel metal hydride, and those don't have too many overheating problems like lithiums. So if we look at the electronics here, you can see a big flyback diode there, or that's what I think that is. Actually, if we take all of it out, you can see that the path is pretty simple. Power comes in here through the battery, and this is actually just a power MOSFET. And what will happen at the switch is that with this direction switch, it'll switch over 2 contacts, so it only needs to use one MOSFET instead of 4 to control both forward and reverse directions of the motor. So power comes in here, gets picked if it's forward or backwards with the switch, and the switch will then conduct to one of these, and then the switch will have current go through the MOSFET and come back, depending on well, it would pulse width modulate that, so it would turn it on and off really fast, coming to the motor, and depending on how far the trigger or how far you pull the trigger, modulating the speed. So if you press it a little bit, obviously it doesn't go fast, but if you press it all the way, it'll just give it all the beans and put the full battery voltage onto here and ground onto here, or the other way around, depending on if you have it in forward or reverse. What you can see here is this motor is a 775 size motor, so that's a 540 right there. Let me see if I have a 775 in my collection of DC motors. So that looks like one. So this is a 775 motor. I've gone ahead and opened it at some point. I think it must have broke or something. These are pretty cheap. Let's see if we can see any branding on this. I'm guessing that's some sort of symbol there, but not too versed in my motor brands. Anyway, it's a bigger motor. Most drills that I've seen, or most battery powered things from back in the day, used something like this. But with a bigger motor, with a larger diameter, I suppose, you can get more current out, or not more current, you can get more torque out, and you can just, well, it's a bigger motor, you can output more power out of it. So I suppose this would have been a pretty powerful drill for 2005, being able to put in some thicker screws, I suppose. So here we see the gearbox. Just we've been seeing these for a while. Just this nylon casing here, plastic casing, and it just comes apart. There's no screws, it just rotates together. And then it just has a gear switch here which engages and disengages a planetary gear set, or it engages and disengages the ring gear of a planetary gear set. So there you see the pinion, and what they did in this is pretty smart actually. They have the pinion with a shaft protruding out of it, and that can go into the planet carrier in here. So it's not a bearing, but it will bind it up in there, doesn't let it get off center, and such. So that's pretty decent. I'm gonna get me some paper, because there it is oozing some stuff out of here. So yeah, there's the motor. Very simple design. And what the flyback diode, I forgot to go over this, but what the flyback diode is for is when you stop a motor like this, when you let go of the trigger, the motor wants to keep spinning because it was already in motion. So when the motor slows down, it'll actually put the opposite voltage of what you put into this, and it will push it back down the line. And if you don't have this flyback diode, it can burn up your MOSFET, because the MOSFETs usually have a little diode in there just for this purpose. But you need this extra big diode right here for I don't know, to dissipate all the power coming off the motor when you let go of the trigger. So yeah, very simple construction here, just soldered onto the tabs of the switch. I forgot to go over. It is a don't see much branding on there either. Made in China. Would probably be pretty decent. It's got these push-in connectors, and the way you get them off is you open this piece right here, and then you can pull them out. Another bad side of that is if you go to take it apart, they kind of just come out on their own. So yeah, you got to remember where you put them, you got to remember to put them back in the right spots there, but that shouldn't be too hard. So now we can get onto the gearbox. So the first thing we have right here is just a thrust washer plate, pretty much, which should have actually, it goes in the same slots as this thing. So what it does is it acts like a bearing surface. Instead of the gears rubbing on the gears rubbing on the plastic there, rubs on this metal. And what already popped out is the ring gear here for the first stage, and it doesn't seem to be impacted by this at all. So the ring gear is also metal instead of riding in the plastic, obviously. And if we go ahead and take the first stage off, we get the second stage right away. But what we notice with the second stage is that there is no rod sticking out of this one. So clearly the higher rotational speed of, this part right here, it needs that stability in there. But I guess this next part goes slow enough where it doesn't matter, and that these can contain it completely. And what we also notice is that the next, well, that is actually pretty odd. What we get here is a plastic ring gear, which is odd to me because you'd imagine the first stage not having that much torque. The forces aren't so big on this. The rotation speed is big, but the forces aren't big. So you'd imagine that the second stage would have thicker gears and a metal ring gear there, but it doesn't, which is not at all what I was expecting, because usually what you will have in planetary gearboxes is that the gears on the first stage are thinner than on the second stage, which doesn't seem to be the case here, because of the lower torque on the first stage. So if we go ahead and pull this stuff out, well, there comes the second stage. And what we can notice with that is that's a lot thicker than something like, whoops, it's a lot thicker than this one. And that's because of the higher torque down there. But if we go ahead and, right, so, yeah, so this ring gear here is what gets moved up and down by this thing here. So what we can actually do is just kind of pull it out like that, because it is plastic after all. I'm sure they put in a plastic part. It's nylon, just because it needs to move up and down and mesh with these teeth down here when you push this up and down. But if we take out the next rotational bushing here, which might actually have to come out through the bottom. Yeah, I'd say that might have to come out through the bottom because it really doesn't want to come out. So I'm going to go ahead and take off these 4 screws down here, which will actually, when I take them off, there's going to be a spring or a few springs in here that'll want to come apart. A thick plate there, that's got to be eighth of an inch, 3 millimeters. And oh yeah, alright, so first thing that popped out, bearings with a retainer there, probably a nylon retainer. And what we get out is this piece right here, which also had ball bearings in there. which were riding on this metal surface. So overall, this drill does have quite a few bearing surfaces on a lot of things, making the wear minimal. Because on modern drills, what they'll have are just plastic wear surfaces that just wear over time, and the product is just, and the drill is just designed to deteriorate after some time. So that's nice and thoughtful of them. Although this is a higher echelon drill. This wasn't a home gamer thing at all. So what we have here is there's the big spring that I was talking about, and there's a metal plate for what the balls were spinning on. Now I'll go ahead and explain this mechanism in a moment, but let's go ahead and finish going over the planetary gearbox here. So actually, I might have been wrong about the front part there. It might be that you have to take it apart from right here. Would make more sense, but a second ago it looked like I could have just... a second ago it looked like the dividing line was above there, which it wasn't. So if we pull that off, yeah, there we go. Now we can take the bearing plate off again, and as you can see here, the gears are almost twice as thick as the previous stage. And I mean, they pretty much look like they are. So it's already 3 stages, which means that this motor would have been a pretty high RPM motor at 14.4 volts. Most likely this motor would have been a 24 volt motor, because they come in 12 or 24. And it would have an RPM rating at 24 volts. And it would be quite a lot higher than at 14 volts. But I guess they were still going pretty fast, considering that we're already on the 3rd stage here. Most modern drills, like this one, I think they have 2 stages at most. Some might even have 1. So if we go ahead and pull this ring gear off, as you can see, this ring gear is metal and it's nice and thick. If we take the rest of the bearings out, we can see that actually this gets into the next part here, which was this whole thing that I took apart. And as you can see on the bottom here, we have basically grooves for the ball bearings. These holes go through, and we had ball bearings right here just like this, that would push up against these ridges down here with the spring pressure, and this spring pressure is adjusted by how far you spin this. There's a nut in here, and it moves up and down based on what rotational spot it's in. So that would put more or less spring pressure on the spring, which would push against these bearings, which would push against this metal here. Now, I'm not sure if that's actually like a torque adding mechanism. This stage of the planetary gearbox will actually kick in once these balls have been pushed up far enough to block the rotational path of this right here. I'm not sure if you can see those, but it might just be that this thing spins freely within the housing here. That would be likely because of these grease grooves in here, meaning it could pick up grease from there and rotate. So that might actually be pretty smart, where it'll give you that extra torque once it's getting loaded. So I don't know if that's the feature, or then if it, because what this is for is limiting the torque. So that, because the spring pressure might actually just limit the torque output where it just clicks out. So I got my snap ring pliers out, and I pulled the snap ring out so we can proceed. What I can already see from here is another bearing. Wonder if it's a discrete or a ball bearing. It looks like it's a discrete. Definitely discrete. So no ball bearing, like on these, you would have a ball bearing here, here, and here and here, so 4 in total. A lot easier to make. This you would have to have somebody pack them in there. And if I go ahead and hammer it out, it just comes out as a shaft. And it is literally just a shaft on a bushing. That is very interesting, because what these newer drills have is a one-way clutch, I suppose, where you can't put power that way to the motor from the chuck in either direction, which is what I was expecting to have inside here, which would have been a convenient place to put it. And, well, it isn't. So there was a thrust bearing here, the discrete ball bearing, and that's for when you got your 300-pound gorilla pushing against the wall trying to put a screw in or something, when the screw head isn't matching with the bit you're using. And what this is a radial bearing here, just a bearing surface, no ball bearings, just lubricated two metal surfaces together, and that'll be radial. It'll be for, I don't know, sideways loads on here, which I don't see why they need such a long shaft, because these modern drills, I mean, yeah, they have 2 bearings right here, but they are tiny. If I could find one of those bearings. So I found one of these bearings. This bearing is actually the front bearing from right here, or the back one, I don't remember which one. It's the same size. It's not even a thrust bearing. So these bearings will go out, and that's what happened to this drill. So your drilling forces this way have essentially no bearing loads, because these bearings aren't meant to handle that at all. And the sideways forces on it are handled by 2 sets of bearings instead of this long bearing surface. So this is a decently skookum drill. I wasn't expecting all the bearings in here, which is pretty decent. The one thing that I got confused about was this, why it's nylon and not metal, but I guess it doesn't need to be because it's not even broken after 15 years. And yeah, it's a decent little 14.4 volt drill. I mean, MOSFET is an ST part. The switch I didn't know about. And diode, well, diodes aren't usually branded. So there's that. Motor, probably a decent brand. Overall, I gotta say, I'm really impressed. All the bearing surfaces, the thick plate that was in there, the nice and chunky spring. I mean, look at this thing. They had to machine this whole part. It looks like it is, I can't tell what material it is, but it's probably round stock from right here. And then this piece right here would be metal injection molded or something similar. And these rods might be pressed into it, which they are. You can see, let's see, right there you can see that they're pushed in. So 3 separate, well, these are all the same part, so I'm counting it as 1. But 3 separate parts joined together to make this whole thing. And there's that snap ring groove right there. There's that chuck thread, and then there's the internal screw thread. So, fairly impressive, I do gotta say. So the only thing that it lacks is comfort, but it's a work tool. It doesn't really need to be covered in fur and nice and soft. So, yeah. I do gotta say, would have probably been worth the money in 2005, although I'm assuming drills were pretty expensive back then. But all the discrete, I mean, look at the amount of ball bearings on this table. There. There's probably some that I've left in somewhere, but... Oh, actually, let's go ahead and check this. So this motor has a bushing right here. Sometimes these will have bearings, but the cheaper ones usually have just a bronze porous bushing that has oil or it's been dipped in oil, and it'll soak up oil, and then it'll be pretty decent. Let me right, this thing was from another motor, and as you can see, they'll have this bushing, and it's kind of like almost like a sphere there, where it can correct its axis, so that if this thing is put in crooked, it can still spin in there just fine. So yeah, I definitely learned something this time, and I hope you did too. See ya.